Hello friends, Jim here with Science Talk. Another story involving the red planet, Mars. And it has to do with water. And there are indications that Mars may have a significantly substantial amount of water hidden deep underground. Dark streaks known as recurring slope linea, RSL, on the walls of Mars' Palliser crater, as observed by the NASA's Mars Reconnaissance Orbiter. RSL streaks may be evidence of liquid water. The water thought to be responsible for and these are dark streaks that appear seasonally. That's another important aspect to keep in mind. May be coming from very deep underground, a new study suggests. So the paper appears in the journal Nature Geoscience. A co-author is Issam Hegyi, who is a research scientist at the University of Southern California and NASA's Jet Propulsion Laboratory in Pasadena, Cal. He states that these streaks, known as the RSL, appear on some Martian slopes during warm parts of the year. Scientists have posited that RSL are caused by transient flows of briny water, it has a high salinity basically, water at or just beneath the planet's surface. We suggest that this may not be true, said Dr. Hegyi. We propose an alternative hypothesis that they originate from a deep, pressurized groundwater source which comes to the surface moving upward along ground cracks that follow a path of least resistance. And Dr. Hegyi does mean deep. The aquifers feeding the RSL likely lie about 750 meters underground, almost 2,500 feet, according to the new study. Hegyi and lead author Abu Talib is a postdoctoral research associate at USC, and he examined imagery captured by the Mars Reconnaissance Orbiter, which found these RSL back in 2011. They looked specifically at 3 RSL-bearing craters as well as streaks in the huge canyon complex of Valles Marineris. Abu Talib and Hegyi found a spatial correlation between RSL and tectonic and impact-related faults, features that could facilitate the movement of water from deep underground to the surface. Okay, spatial correlation. That basically means that the features they're looking at, like these faults, correlated well with the RSL. That's basically what they're saying. And what I mean by correlation is they're able to statistically calculate the correlation and apply a significance level to it. This research pair also modeled heat flow in the Martian subsurface and studied underground water movement in desert regions here on Earth. So basically, by looking at what goes on in processes on Earth, you might be able to get an idea, not do a perfect extrapolation, but you get a very good idea of similar possible processes taking place on Mars. These various lines of research indicate that RSL water is probably coming from deeply buried briny aquifers, the researchers suggest. The experience we gained from our research in desert hydrology was the cornerstone in reaching this conclusion, Dr. Abu Talib stated. We have seen the same mechanisms in the North African Sahara and in the Arabian Peninsula. It helped us explore the same mechanism on Mars. So they put forth a possible mechanism for the seasonality of RSL, and basically it summed up as follows. The system shuts down during winter seasons when the ascending near-surface water freezes within the fall pathways. It resumes during the summer seasons when brine temperatures rise above the freezing point. If Dr. Abu Talib and Hegyi are right, or correct, Mars' deep underwater system is more extensive than previously thought. Last year, Europe's Mars Express orbiter found evidence for a large subsurface lake near the planet's south pole. The signs of aquifers at lower latitudes have been lacking to date, have not been found yet, basically. Now, this is by far not the last word on RSL, but because not every scientist thinks that those streaks is evidence of liquid water. Some consider that there could be dry landslides as a likely explanation. It might even be dry ice, frozen CO2. So, like anything else in science, the debate is on, and as more information is gathered, we can then see who is correct in the debates, basically, and what these streaks actually ultimately turn out to be. But it's kind of fascinating. I just did a report about methane being definitely confirmed being on Mars. Now, possibility of water. Who's to say? Are there Martian microbes? We need to go there and find out. Get the samples, avoid contamination, test it, and then we'll know. But all in all, this is still quite exciting. Thank you for your time. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.